Welcome back. So I hope the basics of binomial theorem till now, the key terms related to that are clear by now. Now this part is specifically for binomial coefficients. Okay, whatever NCRs we have done till now how they will be behaving under different circumstances, that we will be studying in this part. So let's begin the journey of IIT from this part. Starting with the first property of binomial coefficients, this we have already, as we have already discussed this property, that NCR1 and NCR2, if they are equal, there are two possible cases: either both are equal or their sum is uh, equal to n. And again, I will be specifying here again that we are studying binomial coefficients, so we are not looking at the expansion. Basically, we are not concerned about these terms. So in this expansion, we are just studying that how the binomial coefficients, which are these things C part, they are behaving. Okay, so this was a property which we discussed. Now this is again a very important property. Now this helps us when a series of binomial coefficients are given such that satisfying this relation, or I can write this as maybe NCR plus NCR plus 1. You can write this as n plus 1 CR plus 1. Now what do you need to keep in mind in this? That n has to be same. Okay, now series will be such that the next part of n will be increased. For example, if I take here 4c3 plus maybe 4c4, plus next term will automatically be 5c4, 6c4. Now we will see that when the n is constant, then we are getting it from one expansion. Now but when this is same, okay, so how to reduce this? Again, when you will combine these two, it will form 5c4. Now 5c4 and this can be combined, and this way the series will progress basically. Okay, and again, as we see here, that this you have to be keeping the higher one. Now in this case it was r. Okay, so this will be the greater one, and you have to add 1 to that. Okay, so just keep that in mind, that whenever you're doing this thing, whether it is r minus 1, r plus 1, doesn't matter. Write C, increase the index by 1 and keep the higher value of the two. Okay, if they are consecutive, but the thing is that they should be consecutive. We can again prove by expanding this like this: r factorial over n minus r factorial plus this. You can check yourself, and this will ultimately go to n plus 1 CR. Just solve the left hand side, you will get the right hand side. Okay, so next property, again one of the most important properties for IIT-JEE. This we will be using in many cases. Okay, very important. Okay, now NCR into R is equal to n into n minus. Again you can go for the expansion. Okay, so this will be n factorial, this will be r factorial, n minus r factorial, and this if I write, it will be n minus 1 factorial over r minus 1 factorial into n minus 1 minus r plus 1 will be n minus 1. Now only thing which we need to do is to make it in this form is multiply this by n. So we will be dividing it by n, multiplying this r by r, and multiply the overall by r. So this factor actually becomes this thing only. So I can write this basically r by n, NCR is equal to n minus 1 CR minus 1. Again, don't get confused with the plus or minus sign. That is just means somewhere you will see plus here, plus 1. So in that case it will become r plus 1, n plus 1, and it will be on the other side. And always note that in the case where obviously r has to be smaller than n. Okay, so if you're writing NCR and n minus 1, which of them is smaller one? If you need a trick that how we remember because the students, they get confusion in r and n. Okay, so always remember that NCR is greater than n minus 1 CR minus 1. Okay, so this way if I multiply it by smaller one and this by bigger one, the equality will be true. Again, I'm not going for the exceptional cases that when n is equal to r or like that, but I'm just talking about a normal case when r is smaller than n. So obviously, to make this equal, with the smaller one means n minus 1, r minus 1, you will put n, and the other one you will be putting r, okay? So next property after this, again the same property which was listed over, but in terms of NCR, okay? Same property, but only thing is instead of n we have put it n plus 1, c plus 1, okay? And again in this one, this becomes smaller now, so n plus 1 will be with this divided, and again this we will be using when we will be basically doing the summation, okay? Why? Because in the series you will be given in r plus 1 form, maybe r plus 1 something NCR like this, okay? So obviously if you are given something like this, okay, I can from this relation, suppose it was, I may convert it like this by changing the limits, okay? And what I will do, I'll just convert this as n plus 1 NCR, and this n plus 1 is constant. Why? Because n is constant, so you just need to have the summation. We will do a question based on this so that this can be immediately put into the application, because this is one of the important formula. Let us look at some more properties. So the next property, again, if we are representing the coefficients by this, that's already clear, okay? So again, one more thing here is noted here is that n is being removed. So again, this is another way you will see C1 plus C2 plus C3. Now this actually means that n is already being taken care of, that whatever the index was, you're considering a general term, okay? Now another way you will see somewhere in the books will be like this, NC1, NC2 with this rounded bracket. This also means NC1, okay? Either you can go for this, go for this, go for this, but this is the most commonly used, okay? Now this is the sum of coefficients, okay? Now if you carefully look at the expansion, I'll change the color, okay? So if you look at the expansion of x plus y raised to power n, what we will get? We see here that this was getting out to be nc0 x raised to power n y raised to power 0 plus nc1 x raised to power n minus 1 y1, and it goes on. Now we are just needing the coefficients. So always remember, in this expansion you have two sides, left hand side and r. Whatever you want on RHS, you can always get through LHS. So in this, as we can see that on RHS we are just requiring coefficients. There is no x and y. So if I put x and y is equal to 1, okay, so that makes my job easier, that I get it the right hand side, which is the required left hand side of my proof, and I'll see what it becomes here. So it will be 1 plus 1 raised to power n, 2 raised to power n. So I can say that the sum of coefficients will be 2 raised to power n, okay? So this is again very important, that throughout the binomial, whenever we will be playing with the coefficients, we always keep in mind, always have this expansion. And this is again submission, NCR x raised to power n minus r, this is y raised to power r. So always use this thing to get the results. Always, we will be always using this thing to get the whatever is required in the question. Next property says that alternate is 0. Obviously, now what is the change here? That instead of 1 plus 1, we substituted y as minus 1. Why? As you can see here that this will be y raised to power 0, this will be y raised to power 1. So this will be plus 1, minus 1, alternatively it will go. You can just check, it will become 0. One more important result we will get from here is that I can have C0, C2 plus C4 minus C1, C2, C3, C5. This will be 0. So basically even coefficients are equal to odd coefficients, okay? Now this is the next property, as I've quoted that out. This is already stated here that even coefficients, they are equal to odd. And again, since both are equal, then 2 raised to power n was total, odd plus even. Now if we are saying, when I'm saying odd coefficients, even coefficients, I'm just talking about the r value. Okay, odd means having odd hours, and even means having even hours. So in that case, odd plus even is 2 raised to power n. When I'm saying both are equal, it means twice of odd will be equal to 2 raised to power n. So obviously odd and even they will be 2 raised to power n divided by 2, that is 2 raised to power n minus. These properties are again very important. Please note that this will be forming your starting of JEE level. So obviously we need to have these properties with us, because you will see application of these properties everywhere. You will be given, suppose maybe an expansion like this, maybe a multinomial that we will be discussing in the coming parts. So this raised to power n is suppose x plus maybe x square plus x cube, like this, a1 a2 a3. So you will always be using that, you will substitute some values here and you will get some answers, and again the options will be then which of the following is true. That it will say that suppose I started with a0 minus a1 plus a2 plus a3, so you have to just substitute values of x such that you get your desired result. Okay, so in this case alternate minus sign was there, so it means we need to substitute x as -1. Now when you substitute it as -1, you just need to first make ensure that your right hand side, whatever you're following, is becoming the question itself from the given expansion. Okay, this is, suppose this will be given, the thing which I have mentioned, this will be given. So this thing, from this thing you have to derive whatever in the question is. So obviously your right hand side will become ultimately the question. Okay, so from this you have to basically get the question, and whatever you substitute here to make the question, the answer will be the left hand side itself. That is the whole crux which we will be doing in the throughout the binomial. We will be studying more about that. Let's do a question based on the properties which we have done. So the question says, find the value of this thing. Again, spot on question that I was talking about. That in this case, again you see, if I basically start substituting 2 by 1 NC0 plus 3 by 2, what I am doing, I am putting R0, R1. I guess all of you must be comfortable with summation notation. Otherwise pause and go for this first. Okay, that what is this? Okay, in case you are not getting that. As C1 plus 4 by 3 C2. Now if I am gonna do this, I cannot, I'll fall ill basically doing this. If I am trying to, even if I try to do this like this, NC0 x raised to power n plus NC1 x raised to power n minus 1 y. So I cannot get any pattern basically in terms of powers. Okay, this is just going random. Okay, so obviously this is wrong. This is not the way. Okay, first thing we can see that this is r plus 1 over r plus 1. So this becomes 1 plus r 1 by r plus 1. Okay, now NCR, I know the summation NCR means sum of all coefficients. We just now discussed it, it was 2 raised to power n. So this part gets over. Okay, very simple. Now talking about this part again, now even if I get this again, what I'll do, I'll again start substituting. I put R0, I'll get NC0 by 1. I'll put R as 1, I'll get 2. I'll put 2, 3. Again, no pattern in terms of power, because when I'm seeing powers, then only I can substitute. Suppose everything was constant, then I could have taken that, put 1 here. Okay, but we cannot do that. Okay, so in this case, the property of this thing comes very handy. That this was equal to, if you remember, r plus 1. Here it will be n plus 1. So this is the bigger one basically. Okay, so this will get okay, let's open it up and see, derive the property. We will have a proof here also. So NCR basically is n factorial r factorial, this is n minus r factorial. Okay, now what I am getting here is r plus 1 is already there. Okay, so I can make this as r plus 1 factorial. Yes, now here what I'll do, n plus 1 minus r plus 1 factorial. Okay, now in numerator what do I need? N factorial is already there, n plus 1 and n plus 1. Now what I have done here is I've used this thing here, r plus 1 instead of r, and I've substituted n according to that, okay. Now n I am converting into n plus 1 factorial using this thing, okay. So this is very again, this is basically derivation of that how we can basically remove this r plus 1 to get into n plus 1. So this will be n plus 1 into, now again this will become n plus 1 factorial, this term, so basically this will become n plus 1 c r plus 1 divided by n plus 1. So now again this will be equal to the term which we have written there, x plus r plus 1, okay. So keep that in mind. This one was multiplying with here smaller one, okay. The thing which I was about to say here was that this will be equal to n plus 1 c r plus 1, the smaller bigger one with the smaller one with the bigger one, okay. Now this series becomes very easy. How? Now you can just see that you substitute from n, and again please keep in mind the n starts from 0 to n, okay. So I'll write it here. The earlier one was 2 raised to power n, which we got from here, plus, now what is my term? Summation. This is r from 0 to n, 1 by n plus 1. Now this 1 plus n I can basically take outside. The only concern is n plus 1 c r plus 1. Now only thing here is that when you will put 0 here, you will start with nc1 c1 plus nc2 n plus 1, and you will go up to n plus 1 r plus 1. Now this is what common mistakes students do. They write this as 2 raised to power n plus 1. Again, to be noted, not to be done. Why? Because we need n plus c0 also. So we will add this and we'll subtract this. So n plus 1 c0, by now all of you must be knowing this is 1. So this will be 2 raised to power n plus 1 minus 1. Now again note that since we were doing for n here, 2 raised to power n was, now if this index is n plus 1, the coefficients will also go till, the coefficients also become n plus 1, okay. So not to be confused that how does this n plus 1, that is just the index, that whatever is a power will automatically deflect in this thing, okay. So this is how we will get that this will be 2 raised to power n plus 1. So I'll write final answer here. So this will be 2 raised to power n, okay, plus 2 raised to power n plus 1 minus 1 divided by n plus 1. So I guess this clears the things that how we are going to use the properties and how expansion we are going to use the sum of binomial coefficients and all that. We'll be doing great deal of properties and great deal of application in the coming things. So please make sure that you are doing this correctly and revise all the properties. This is for this question only. I hope you have noted down the important properties which were taught in the chapter. So I guess by now you must be feeling okay, now the things are becoming bit complex. Wait, complexities are yet to come. Stay tuned for the next part.